Hey everybody, this is Mr. Walsh, and in this video we're going to talk about percent error and how it kind of is the measure of accuracy. We have talked about accuracy in a previous video, and so percent error is how we measure how accurate a number is. And so we can figure out that percentage and then determine whether we're accurate or not accurate, or kind of accurate or really accurate. And so here's the thing, the higher the percentage, the more that there's error. So if you have a 75% error, that's a high percentage, and that means that you're not very accurate. The same thing is true, or the opposite is true with low percentages. Okay, I mean, if you have a 2% error, that's a very low error, and that means you are very accurate. And at some point, remember I said that accuracy is, if you want to be considered accurate, you should be within about 10%. Okay, and that level can change, but for the purposes of this class, 10% is and the formula that you have for percent error is down here, and I will typically give you this formula often, all the time. Okay, and you have the measured value minus the accepted value, and you take the percent, the absolute value of that, and then you divide it by the accepted value, and you multiply it by 100 to get the percentage. Okay, now some of the vocabulary is, it may not in the problem say that it's measured, it also may be estimated or guessed. Okay, it's whatever the scientist or the person comes up with, and then the accepted value may also be written as the actual value. Okay, so there's some vocabulary, and that's actually more of the problem than doing the math usually, is making sure that you know which value is which. So we have an example here. We have a student that measured the mass of a rock and found it to be 300 grams. So I'm going to write right in here that this is the measured value. I'm just going to abbreviate it MEJ. Okay, and the actual mass is 250. Okay, so again, notice that here we didn't use accepted, we used the actual, but I'm going to write here that that's the accepted value. So now it's time to do the math. So it's the percent equals the absolute value of the measured minus the accepted over the accepted times 100. Okay, that's the formula that you're given. And then the measured value is 300 minus 250. And we take the absolute value of that, we put that over 250 times 100. Okay, so it's the measured minus the actual divided by the actual. Measured, actual, actual. Okay, and then we now do the math. 300 minus 250. If you need a calculator, there's a calculator, you can use the calculator. I don't need the calculator to do this. I've done this problem a couple of times. So 300 minus 250 is 50, and then the absolute value means we ignore that it's either positive or negative. We just have it as a non-positive or negative number, and then we put it over 250 because that's still on the bottom here, and then times 100. So again, 50 divided by 250. If you need a calculator to do that, feel free to grab it, use it. When you do it, you'll get 50 over 250 is 0.2, and then we multiply that by 100, and that's going to equal 20%. Okay, so this is not very accurate. Okay, this measurement is not very accurate. So another example, I go down to Long Beach, or I think that to rent a jet ski, it's going to cost $200. So this is another way of saying a measured value. I kind of guessed, or I thought that it was going to be here, so I'm going to put that as a measured value, and it costs $250. So this is the accepted value, the actual value, and now we want to do the math and figure out what the percent error is. Okay, so good thing I have some space down here. Percent equals the absolute value of the measured minus the accepted over the accepted times 100. So we're going to go 200 minus 250, absolute value, over 250 times 100. And so here, 200 minus 250, you put it in your calculator, you get negative 50, but the absolute value, make sure we get rid of the negative, so it's 50 over 250 times 100, which then equals 0.2 times 100, which is 20% again. Okay, so again, my guess was not very accurate. I was off by about 20%, and so scientifically I am not very accurate. Okay, so there you have it.